Hello, everyone. On this podcast, I bring you Harald Breivik from Condalign Technology. Harold's the CEO from Condalign out of Oslo, Norway. He introduces the Condalign E-Align technology. Excited to have you learn about this really innovative material, some of the technical advantages that Condalign brings over traditional conductive epoxy methods in printed electronics, some of the challenges in the adoption, how we're collaborating together to bring this new technology to market, some of the innovative applications that the new technology brings, market opportunities. So bringing you Harold from Condalign. Thank you. Okay, well, hello everyone. Welcome to the next episode of the podcast, the Better Product Solutions podcast. Happy to have Harald Breivik, CEO of Condalign, on the podcast. Harold, I see snow in the background. We were just talking about how we both drove in with snow this morning. So obviously, you can give your introduction on where you're sitting right now. And so if you could, Harold, introduce yourself and introduce your company, Condalign.
Yeah, hello. My name is Harald Breivik, as you've already said. I'm the CEO of Condalign, a technology company based in Oslo, Norway. So as you can see on the back here, we have snow today. It's been quite busy on the roads. I'm here to discuss with Stevie our cooperation with Tapecon on our conductive products and our technology. And I'm leading a team here in Oslo of approximately 20 plus people. We are developing and commercializing and producing conductive material.
Yeah, I know, of course, we had some social media publicity on our collaboration, so I'm excited to talk more about that. And then our team met. I didn't meet you guys for the first time when we were over in Germany at that show, but some of our team did, and so we met, and there's obviously a lot of alignment. So it's great to see, this collaboration continue, and now I got you on the podcast. So, Harold, on Condalign, so can you explain the core technology behind Condalign and maybe give the teaser of some of the primary applications and really how you guys have emerged on the scene here?
Yeah, so that I would do happy to be here on this podcast. In Condalign, we have a patented technology which allows us to manufacture and develop a very specific and specialized product. It's a conductive material. So in the sense of coating in a roll-to-roll setting, we are able to manufacture a film which contains a polymer and particles where we are able to align the particles in C direction of the film. So when you receive the product from Condalign, you will receive a conductive film where the particles inside are aligned in the C direction of the film, giving you an anisotropic conductive film. So with me, I've brought this picture showing how, in theory, our film looks inside when you receive it. So here you can see the polymer matrix with the conductive particles stacked in organized rows. So this could be both thermal conductive particles and it could be electric conductive particles. So over the last 3 years, we have developed and commercialized different kind of conductive materials. So we have the E-Align series, which is the electric conductive film, which is utilized to bond electronic components. And then we have the thermal conductive film, which is a heat transfer material, a very efficient one, and very beneficial material properties.
So on your website, Harold, that picture that you were showing, because I know if someone's listening to this, they won't be able to see it. Yes. But on your website too, I remember there's kind of some movement on the website showing the particles actually aligning also, right?
Yeah, so that is the patented process that we have in-house. So when we are coating the film, we are mixing the polymer and we are mixing the particle into a slurry. And then we are coating through the coating line. And then in this process, we have a special made alignment unit made and developed by Condalign, where we align the particles as you see on the picture. And then we cure it as the particles are aligned. And then we roll it onto rolls. So the final product in our roll-to-roll manufacturing machine would typically look like this. So in this film, all the particles are aligned in strings in the Z direction of the film, as you saw on the picture. So this is a electric conductive film, a product that on our website is sold as E-Align.
Yep, E-Align, hence the E for the electric. And there's obviously, there's a market already out there in flexible electronics and printed electronics where people are obviously placing electrical components, but using, traditional conductive epoxy. So what are the kind of technical advantages? I mean, like why Condalign film over the traditional method, the tried and true conductive epoxy and conventional type applications? What's the real technical advantage with the Condalign product?
Yeah, that's a good question, Stephen. That's the differentiator between our material and the alternative is that our material works more like a double-sided tape. It's a pressure-sensitive adhesive. So I have a small sample with me here. It comes with 2 liners. It can be supplied on rolls, different shapes. But when you peel off one of the liners, you can see that the material is adhesive. So it works like a double-sided tape, and it can bond electrical components without high pressure and high temperature and no curing. So you add the film onto the substrate, and then you put the component on top of the film, and then you're done, and you're connected with the bonding. So from a assembly point of view, it's quicker, and it allows you also to bond on heat and pressure sensitive materials. So you are able to use more biodegradable products. You can bond electronics on paper and different materials that is sensitive to high pressure and high temperature. But if you look at a typical example, this is a demonstration unit that we have developed together with one of our clients, Condish. Here you can see the printed electronics on the backside.
Yep.
You see a printed battery. You see a display as well on this side, and you see some LEDs. And we have then used our film to bond the different components in these kind of laminated products. So we put it in as a layer between the connection pads on the units.
Is there a tactile push button on there also? I think I saw a. Is there?
Yeah,
It looks like there's a button.
There is a push button. So when I push the button, it will light up, as you see. Yep. There is still some battery. This is not it's not a rechargeable battery, so it will probably run out of power soon. But this is one application. Another application is here. You can see we have a screen with a conductive stripe on the side. This is for EMI shielding on the screen for bonding without using high pressure and high temperature. You can just tape on this, and you have the conductive connection. Here we also have a small electronics unit where you can see that the display is bonded onto the electronics platform using a double-sided tape, and it helps on application speed because you don't need to heat up high pressure or curing. You just tape it together. So we have a wide range of applications where we are working on with clients, and this is also an example with one of our clients, Hivsox, where they have a kind of a smart car design, slim, where they are using our technology to bond the display and also bond the flexible battery on the backside of the unit. So there is a lot of different kind of applications, but we have in our commercialization of the products, we have, of course, focused on specific use cases and use areas for this.
Yep, and I think people who know Tapecon obviously are now putting two and two together and understanding why we've come together here. I mean, obviously a pressure sensitive adhesive construction in a disruptive technology versus the traditional with our capabilities aligns perfectly. And the low temperature substrate is huge because oftentimes the largest cost of the bill of material can oftentimes be the substrate, which is required to be able to withstand higher temperatures. So the differentiation of going to a low temperature substrate is huge in terms of reducing cost out of a design, and it opens up the designer's playbook a little bit into more environmentally friendly substrates. As you said, paper. I mean, you're doing a lot of things on paper, totally different than kind of the traditional industry that's using these conductive epoxies that require really high temperatures, right? I mean, because even the low temperature stuff is still not that low, right?
No,
When you compare to what substrates it can withstand, right?
No, so typically low pressure in traditional terms is typically above 100 degrees C. So it's still a very significant temperature to expose to a lot of materials. And we do this at room temperature. We bond at room temperature. So we bond at different substrates. Here you see a paper label where they have bonded batteries inside, flexible batteries inside with our film.
Yep.
I also have it's not a high professional unit, but here you see some solar cell or some photovoltaic displays and some LEDs. I'm not sure if you're able to see this, but you can see that both the LEDs and the power units are bonded to this substrate using our double-sided film. It's done at room temperature. And just to kind of show the functionality of this and the simplification, I can try to light up on one of the cells. You would probably see that it's lighting up.
Yeah, it's lighting up. Yep.
And also, even the LEDs on this substrate is bonded with our film. So this is a kind of there's no one else able to do this without high temperature and high pressure or any kind of curing. So we are pretty proud about the capability of this technology.
Well, I mean, obviously, one of the exciting things about being the disruptor is you're coming with the new technology, but it also brings its challenges in that you have an ecosystem that is pretty used to what they've been using. So you face a challenge of getting first movers, to say yes and start developing a crowd and a community, and eventually evangelists around your new solution. So I mean, so what are some of the challenges that an engineer? So if I'm an engineer, I'm looking at developing a new product. I'm considering these types of bonding solutions, and of course, it's the easy road is looking traditional, but as you said, you're going to run into issues with temperature and some of these other challenges in the processing side. So what are some of those challenges that the engineers face when they're going to integrate some of these new materials like your film into their existing process, or if they're starting up something new, what considerations should they have or challenges?
Yeah, so first of all, we have a wide range of different clients that we are currently working with. There is a lot of differences between the different clients, but there are some kind of common rules that we also guide on when they are testing and implementing and designing in our product. So there, first of all, our film, we do not require high pressure and high temperature. It's not prepared for soldering. So first of all, we see that a lot of clients, they have to remove the solder mask. So that is one part of it. The surface finish of the bonding surfaces needs to be prepared for our film. It needs to be flat because it's very tiny tolerances. So that is the kind of the interface part of it. But then you also have the integration part of which comes into your part of the business, which is applying a label onto electronics. And in the label industry, you don't necessarily look at placing a label as a kind of a big issue. But in the electronics industry, we do see that it's not that commonly used to place labels into a kind of a manufacturing line for electronics. So in the development of a roll-to-roll process for building flexible electronics, we see that it's very useful to work with companies like yourself to help integrate the placement of the film onto the substrate. And then, of course, when you have the film onto the substrate, you can use a regular pick and place machine to place the electronics. But in conventional systems, you either have a soldering machine or a kind of a conductive glue or paste that you apply, which is regularly used. But placing a tape or a double-sided tape as we have is slightly different. So that's where we see that we need to spend a bit of work. And also that's why we think it's very interesting to work with a company like Tapecon.
Yeah, placing drops of in essence glue and then placing components on is a lot different than what we're really talking about here is using laminating technologies and creating laminating based circuits.
Yeah.
And so with new materials comes a new manufacturing process development. And so certainly collaborating with our two organizations brings some application-oriented specific capabilities that Tapecon brings with your technology. So it's going to be really exciting in the upcoming year on seeing the emergence of some of these applications and us working through some of those challenges. So you've already shared, I mean, a lot on the screen and some of these kind of really innovative applications. If you kind of boil them into, say, segments or application areas, where do you think the big exciting application categories kind of fall then?
Yeah, so currently we have been approached by a huge range of different companies and different application areas, but we see that there are some trends and tendencies in growing markets. We see that smart labels like this is attractive to a lot of our clients. This one and similar ones are being developed by a range of different companies, and they have been attracted by our technology due to the cost of the product, but also the application speed. We also see kind of RFID or bonding as a kind of a growing future market for us. We see the smart card tracking as very attractive because we see it's a growing market and it's requiring new solutions in order to bring down the cost, and not the least bringing display solutions into different kind of end products. It could be smart cards, it could be smart labels, it could be medical devices that would require a label, and then our film with the flexibility and the slimness of the film will be a very good solution, and not the least the area within medical patches, where we see that our film is an enabler for a lot of different solutions, being one layer in a stack of a laminated product. So we are currently focusing on these areas. In addition to this, we, as I mentioned in the start, we are also manufacturing this thermal material, which is transporting heat. It's addressing a completely different market, but we are using the same manufacturing technology to make this thermal interface material very cost efficient and very beneficial mechanical properties. So this is the kind of the areas that we are currently focusing on. We see that the application areas and potential of the technology is much bigger, but as a small company, we need to kind of focus, and we are going for the low-hanging fruits, and we see that the traction is very good within the areas that I just mentioned. So we are very happy with that. So that's how we are looking at the future. So
yeah, well, it's exciting. The core technology, of course, being both on the electronic side and the thermal interface materials. I understand they're different and they're solving different problems, but it seems the persona of who your end user customer is still that electronics engineer persona that has both of those challenges. I mean,
Yes.
The same person has to answer the heat dissipative challenges that exist in whatever design they're using. If the product, of course, just needs that solution, but then, of course, there's other products that are more electrical in nature, the smart labeling, the smart cards, adding a display feature. It's still going to be that electronics engineering skill set person that's going to ultimately specify your product. Did I have that right?
Yeah, that's true. We see that the kind of the electric film is kind of a more innovative product with the thermal interface material. We use the same technology, but we see that the end product is, by handling and integrating into the production lines, are much more similar to what is already existing in the market. So there you can kind of replace an existing material with ours due to the performance of the material and the high performance of the material at a very beneficial cost. While within the electronics area, we are more kind of changing the way things are assembled.
Right. But both the bill of material simplification, cost reduction, and if the processing is figured out to be more cost efficient, which of course that's starting to really evolve and show a valid use case, then it really could be both a cost savings on the material side as well as production process too. Especially when you talk about really high volumes, I have to imagine a laminated process can be a lot higher volume. You go to a lot of these, even if you just go into a basic PCBA manufacturing facility, it's usually, sheet by sheet type processing. Not, no one's doing this stuff in continuous roll to roll processing, but that really opens up, this kind of Internet of Everything, or the electrification of a lot of use cases that currently you just don't feel that electrification.
Yeah. That's correct, and I think with our solutions and a pretty advanced product, we are able to, as I showed you on this wall, this is a 300 millimeter wide wall that we have produced on our pilot machine in Oslo. We are planning wider manufacturing in large scale, up to 600 millimeter. And then you end up with a very cost-efficient manufacturing process for a very advanced product.
Yep. Okay, well, those were all my questions, Harald. Is there anything else you want to add before we close in terms of, obviously your website, there's a lot of information on your website. There's sample materials available upon request for people to do testing. Of course, Tapecon's located here in Buffalo, New York, representing North American side of the world, with you guys over in Oslo. So we've got a lot of area covered here and ready to get these products out and hopefully proof of concept and showing people some prototype scale volume.
Yeah, so what I would say is that typically, if you want sample materials, we have different kind of materials for different kind of applications. It depends on the size of your components. They're all available for sale in smaller or larger volumes on our website. If you require larger volumes, you should of course contact us and request kind of a separate quotation. In the application area, I would also say that we are very happy to support any kind of testing activities with our brilliant application engineers, which is ready to support on how on interfaces on preferred materials, preferred surfaces, giving and transferring experience from other applications and giving you a faster way to a successful solution. So I think that is my kind of key message, is that we are here to support on any kind of applications you want to explore.
Okay. Well, thanks, Harald. Appreciate you coming on the podcast. So last chance for parting words. Otherwise, we'll close. But thanks for the podcast and for coming on.
Thank you for having me, and I'm looking forward to our continued cooperation.
Likewise. Thanks, Harald.